Okay, so for example, let's see what I have here. Okay, so how do let me pose this question for you to you guys. Do scientists how do scientists represent isotopes? You already seen one representation of an isotope. Okay, represent. Let me see. Represent isotopes. Okay, it's blurry. Come on, let's. Okay, there you go. Okay, how do scientists represent isotopes? That's the question that we need to address. There's three different ways of representing isotopes. One way is as such. Okay, where you have the element symbol. So for example, for carbon it will be C. For fluorine it will be F. That will be in this place right here. Here is your what? Your atomic number. Oh, excuse me, this is your mass number. See how that can be confusing? The A could be mistaken for atomic number. That's your mass number. So that's your mass number. Here is your atomic number. Atomic number. Okay, so that's one way of writing an isotope. Another way of writing an isotope is like the way I've been showing you. Here you have your mass number, and here's your element symbol. Okay, and the final way you could write it is as such. Okay, element symbol again, and your mass number. Okay, so let's look at, for example, let's write carbon-12 in all three forms. Okay, so your professor could very well ask you to write, yeah, like I just said, write carbon-12 or write carbon-13 in all three forms. Okay, so for example, carbon-12, that 12, when people say write carbon-12 or write carbon-13, that number that they're referring to at the end of that statement is the mass number. Okay, so carbon-12 can be written as such. That's the element symbol, carbon, and there's the mass number 12. In this format, it will be written as, oops, why am I writing X? It will be C12, right? And this final format, it will be C12. And then Z is atomic number. How can you figure that out? Well, you refer back to the periodic table. Look at the periodic table. Look at carbon right there. That number is, zoom in for you guys, 6. Okay, so you put a 6 there. So there you have it. That's the ways you could write carbon-12 or carbon-13. Let's do it for carbon-13 briefly. Okay, let me lift this up a little bit. Okay, carbon-13, carbon-13. Here's carbon-13 and carbon-13 with a 6. You see how that number remained the same? Like I've been telling you this whole time, the atomic number does not change for one given element. It always remains the same. The only thing that changes for isotopes are the mass numbers. Okay, so there you go, carbon-13. Let's take it one further step. Carbon-14. Carbon-14. Carbon-14, 6. Okay, carbon-14 with a 6. So now we know how to draw these, write out these isotopes. Now let's see what information. So a professor could very well ask you, here you have carbon-12. Tell me the amount of protons, neutrons, what is the mass number, so on and so forth. So let's do that right quick. Let's look at carbon-12. Okay. Okay, so a teacher, for example, could ask you, carbon-12. They could ask you to write it in those three different formats. And after doing that, they could ask you to give some certain information. So for example, they could tell you what is the mass number, so what is A, what is Z, which is the atomic number. They could ask you how many protons, right? They could ask you how many electrons. They could ask you how many neutrons. And let's see, is there any other information that they could ask you? Well, I think that's pretty much it. So let's start off with the atomic number. Actually, the mass number. The mass number is given by the symbol up top. If you look at that formula I've been showing you, right? Not the formula, but that format. If you look at the way that they write this specific isotope, they put the element symbol and they put the mass number up top. So the mass number here is 12. So A is equal to 12. Okay? Because again, the format, the general way of writing an isotope, this is one of the ways, is as such. X with an A up top. And that A is right there. Okay? Now Z, you be like, at this point you're like, wait, how am I figuring out Z? I don't even know what's going on. Well, you can figure out Z in a very easy fashion. You look at the element symbol, right? The element symbol is C. Look at the periodic table. Look for an element symbol that is C, that corresponds to that. C is right there. It has a little number up top. If you recall, that little number up top is the atomic number. It's the number of protons for a given element. So all carbon isotopes, regardless if it's carbon 13, 14, 15, whatever it may be, they all have the atomic number of 6. So Z is 6. You can find that information again from periodic table. I'll put that there, PT, periodic table. Number of protons. How can you find the number of protons? Well, we just did. Atomic number and the amount of protons you have is the exact same thing. 6. Number of electrons. Number of electrons, if you recall from the example with oxygen, I said that in its elemental state. Okay? In the elemental state, oxygen has 8 protons, and what amount of electrons does it need to have a neutral charge? One needs 8 electrons. So we could apply that same type of thinking to carbon. Carbon has 6 protons. In order for it to have a neutral charge at its elemental state, it needs 6 electrons. So 6, there you have it. Finally, what is the amount of neutrons you have? Now we use that formula. If you recall, I told you guys to memorize that certain formula. Number of protons plus number of neutrons equals mass number. We have the mass number, which is 12. We have the proton number, which is 6. All we need is the number of neutrons. And number of neutrons is equal to 6. There you have it. That is the types of questions you can expect relating to isotopes. Okay, basically find specific information. A lot of this information can be found from the periodic table, but just as equivalently, you can find a lot of information from looking at the isotope and looking at the mass number and extrapolating a bunch of information from that. And if I were to write this as this and ask you the same questions, it would have made things easier. You wouldn't even have to refer to the periodic table, because here's your atomic number right there. So number of protons, that takes care of that. The mass number, you already have that up top. Z is the same thing as the number of protons. Number of electrons, if you have 6, you need to have 6. Number of neutrons, you use that formula. You have protons, you have mass number. Just subtract 6 from 12, you get 6. There you have it. And I think this concludes my discussion, a very long-winded discussion, but I really wanted you guys, I know it's a long-winded discussion, but I really wanted you guys to understand and get a very solid grasp, a solid foundation, a solid understanding in this basic general chemistry topics, because I'm telling you, it could come back to haunt you in later classes when you don't understand these things. I'll possibly be uploading another video where you can do calculations on percent abundances, but that might be in the near future. So there you have it. Those are types of questions, those are types of things you can see in regards to isotopes. Hope this is very informational. Thank you for watching, and this is Moballer 12 signing out.